Hey guys, welcome back to another video. Today we will be producing some ethyl acetate through the reaction of ethanol and glacial acetic acid. This is a Fischer Esterification reaction where a carboxylic acid is reacted with an alcohol in the presence of an acid catalyst. To begin, we can measure out 30 milliliters of glacial acetic acid, which I showed how to produce in a previous video. It has become a bit discolored over time as it is quite old, but it will work fine as the final ethyl acetate needs to be distilled to purify it anyhow. This is added to a 100 milliliter round bottom flask, followed by 30 milliliters of 95% ethanol. The ethanol can be purchased in some rubbing alcohols, or it can be fermented and distilled as I showed in a previous video. Usually an excess of alcohol is used in a Fischer esterification to drive the reaction forward. However, in this case, a slight excess of acetic acid is used to hopefully react with all the ethanol and make it easier to purify the ethyl acetate later. After adding the acetic acid and ethanol, a condenser column is added on top, and then 6 milliliters 98% concentrated sulfuric acid is poured in. I also show how to make the sulfuric acid in a previous video. Once the reagents are added to the apparatus, water is circulated through the condenser and the mixture is brought to a reflux using the heating mantle we designed in a previous project. As the mixture refluxes, the sulfuric acid protonates the carbonyl oxygen of the glacial acetic acid, which increases the electrophilicity of the carbonyl carbon. The nucleophilic oxygen of the ethanol then attacks the carbonyl carbon of the acetic acid. The oxonium ion then protonates another ethanol molecule, which in turn protonates one of the hydroxy groups, giving a new oxonium ion. The oxonium ion is lost as water, and then the remaining molecule is deprotonated to give the final ethyl acetate ester. The mixture was held at reflux for 3 hours and then allowed to cool completely. The reflux apparatus was replaced with a simple distillation apparatus, and everything that distilled over below 100 degrees Celsius was collected. The ethyl acetate forms azeotropes with both ethanol and acetic acid, so it is likely that these other components will co-distill with the ethyl acetate. After the distillation, the distillate was added to a separatory funnel, and a saturated sodium bicarbonate solution was prepared. Approximately 30 milliliters of the sodium bicarbonate solution was added to the separatory funnel and capped, vented, and shaken to destroy excess acetic acid. Ethanol should also go into the aqueous phase and be removed. The upper ethyl acetate layer was retained and the lower aqueous layer was discarded. The washing step was repeated with another 20 ml of sodium bicarbonate solution, and then anhydrous calcium chloride was used to remove any residual water in the ethyl acetate. After stirring for around 15 minutes, the ethyl acetate was decanted from the calcium chloride into a 100 milliliter round bottom flask, and a fractional distillation apparatus was set up. If there is any ethanol left, it should distill as an azeotrope with the ethyl acetate and come over first around 71 degrees Celsius. After that, pure ethyl acetate should distill over around 78 degrees Celsius. In total, 12.1 milliliters of ethyl acetate distilled over around 78 degrees Celsius, corresponding to a 23% yield based on the starting ethanol. The low yield is likely because ethanol was made to be the limiting reagent, so the purification would be easier. As mentioned earlier, Fischer esterifications work best when an excess of ethanol is used to drive the reaction forward. This method is definitely not the easiest or cheapest way to produce ethyl acetate, however it is fun and a good example of a Fischer esterification reaction. In a future video, I also plan on demonstrating how to remove ethyl acetate from acetone-free nail polish remover, so keep an eye out for that project. Anyhow, I hope you guys enjoyed, and I'll see you in a future project. Okay, bye.